The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Percentage by Conversion to Fractions. Example, 31% of 8,357. Let us find out the percentage value through fraction procedures. Using the example 31% of 8,357. Convert 31% into a fraction. It is 31 by 100. As there is no common divisor between 31 and 100, further simplification is not possible, and therefore you have to simply take that as the fraction. Since this is a problem of fraction multiplication, the number 8357 can also be treated as a fraction. You can treat this as 8357 by 1, where 8357 is the numerator and 1 is the denominator. There are two fractions, 31 by 100 and 8,357 by 1, and you have to multiply them. You simply multiply the numerators and the multiplied value becomes the dividend of a division problem. Similarly, multiply the denominators and the result number will become the divisor. In this problem, multiply 31 and 8,357 and divide the result by 100. Unlike the previous problems where the division process was mostly involved in finding out the value, in the current problem, multiplication process is very much involved. At this stage, we have to multiply 31 with 8,357, which are treated as the multiplier and the multiplicand, as there are two digits in the multiplier 31 and 4 digits in the multiplicand 8,357. We have to add 1 to the respective digits, and therefore we have to set the multiplicand from the 7th digit from the right side of the abacus. That is, count 7 columns from the right side of the abacus and set 8 there, followed by 3 to its right, 5 to the right of 3, and finally 7 to the right of 5. Now set the multiplier 31 in the left end of the abacus. Let us multiply 7 with 3, which gives 21. That should be set to the right of the 7 in the dividend. That is 21. Now multiply 7 with 1, that is 7. That should be treated as 0, 7. That means 0 added to 1 in the tens column, and 7 is set in the units column. Now clear 7 from the abacus as the multiplication process is over. Now multiply 5 with the 3, which is the highest digit of the multiplier. Now we get 15. That means 1 is set in the thousands column and 5 is added to 2 in the hundreds column, making it as 7. Now 5 is multiplied with 1, that is 0, 5. That means 0 added to 5 and 5 added to 1 in the tens column. Now clear 5 from the abacus. Let us multiply 3 with 3, that is 9. That should be treated as 0, 9, and therefore 0 is set in the 10,000s column and 9 added in the thousands column. As we can't do that, we add 1 in the 10,000s column and subtract 1 in the thousands column. Now 3 is multiplied with 1 and 3 is added in the hundreds column. That is, add 1 in the thousands column and clear 7 in the hundreds column. Now clear the number 3 from the abacus. Now we are left with 8 as part of the multiplicand. Now 8 should be multiplied with 31. That is, 8 multiplied by 3 is 24. That is 2 added in the 100,000s column and 4 added in the 10,000s column. That is, add 5 and clear 1 in the same column. Now finally 8 is multiplied with 1, that is 0, 8. So 0 is added in the 10,000s column and 8 in the thousands column. Now let us clear 8 from the abacus. The result we get here is 2, 5, 9, 0, 6, 7. This is the multiplied value of the numerator and it should be divided by the denominator 100. In the case of 100, it is easy to allocate 2 digits in the right side of the number. That means the divided value is 2590.67. The learning from this problem is whenever you have 100 as the denominator, you have more multiplication process than the division process. When you get in the denominator a number other than 10 or 100, that is multiples of 10, then you have to use the division process to the most than the multiplication process. Hope these types of varieties will fine-tune the skills of the child in using abacus.